Welcome student. Today we are going to learn the new topic that is class study. All you are very much know that or machine learning are just basically the learning concept are distributed in two parts. One is our supervised learning, another is the unsupervised learning. First, we already know in our previous lecture that what is supervised learning. Supervised learning, basically there is a particular supervisor, means there are a group of data. We have to classify this data in a particular known class. Means class is already predefined. This is called our supervised learning. Now, what is our unsupervised learning? Unsupervised learning means there are no any particular supervisor. Means we don't know in which classes the data are classified. Means there are no any particular class that is predefined. We have to make a group based on the characteristics of the data. The most important example or algorithm of the unsupervised learning is that is the clustering. Now today we start our lecture with the clustering algorithm. So already we can define that what is clustering. Let's check what is clustering. It's basically a unsupervised learning procedure. I already tell that the clustering is an unsupervised learning algorithm. Now come to the basic definition of the clustering. Organize data into the class. This is the most important part. Organize data into the class such that there is a high intra-class similarity, low inter-class similarity. I think you don't understand what I'm telling you, that what is high intra-class similarity and what is low inter-class similarity. First, I'll give an example. Suppose there is a lot of students up there in a particular field, and there is some student belongs in a Brunel University, and some students belong in another university like the Techno India University. There are different type of universities there, but I don't know that students at the Brunel University or the students in the Techno India University. I don't know. Only I know that there are lots of students are present in a particular field. Now we have to group the students. How we can group it? We don't know that there is a two groups are there. These are students at Brunel University and students also in Techno India University. We don't know this type of things. Only we know that we have to group the student. So it is natural part that is the similarity between the students of Brunel University is very high, and similarity between the one student of the Brunel University and the students of the Techno India University is definitely very low. So what is our main motto? Our main motto is we have to identify this similarity. We have to identify the similarity between the students. The students who have a high similarity, this is a particular class, and the students does not have a high similarity, those have a low similarity, as a different class. So according to the high similarity, we have to grouping the student into the separate classes, and in a particular class between all the students similarity should be high. Between two classes similarity between the students should be very low. So intra-class similarity is very high and inter-class similarity is very low. Then we can make the students in a group. This is the main concept of the clustering. But most important part is that all the data should be homogeneous data. If data is not homogeneous, then we cannot execute anything. Suppose what do you mean by the homogeneous data? I am taking the example, the students of various university. Suppose there are some employee, suppose there are some student, then it is the homogeneous data? No. We have taken the data that all of the students, we taken the data all of the employee. This is means data are homogeneous. Then you can apply the clustering algorithm. Now the most important part is that clustering should be similar. Clustering should be in a subjective things. It is not the by any virtual thing. This should be the subjective things. I make in the readable mode. Now I am going to the next part. What is the next part? Now I already told it. What is the main concept? The basic of what we are going to group, finding the group in a similar object. That's the main important or motto. That is, we have to finding the group in. We are going to group in a similar object. And now there is a particular graphs are there. Let's check. This is a particular graph. What is the main concept of the graph? Means x1, x2. What do you mean by x1, x2? X1 is a features value and x2 is the features value. So what is the area of this graph? It is the base of features value. It is the base of features. Okay, and there are lots of data are there. Every point and identified is a data. Every point, that is p1, p2, p3, p4, p5, p6, p7, p8 in the up to the pn, means there are lots of points are there in the feature space. And what is our motto? Our motto is we have to classify this data and make a particular group. Not only the classification, it is also classify and make a group. Means we have to make a clustering group. We are identified data in a particular group. So it do mean by the make a clustering. So, and what is the base of execute the clustering? We already defined that. That is high interclass similarity, high intra-class similarity, low interclass similarity, high intra-class similarity, low interclass similarity. Based on this, we are make the group. Now, what is similarity? Now we will explain what is similarity. Similarity is the inverse of distance between 2 points. Identify this in a most important term. Identify it. What is similarity? Similarity is this inverse of distance between 2 points. What do you mean by distance? Suppose this is the point. Suppose the point is P4. Suppose the point of P1. What is the distance? Distance between P1 and P2. There are long distance between P1 and P2. But there are the distance between P1 and there are long distance between P1 and P4, and there are very small distance between P1 and P2. There is a point is P4 and there is a point is P1. There is a long distance between P1 and P4, but there is very small distance between P1 and P2. So P1 and P2, there is a small distance. It means there is a high similar data. Distance between P1 and P4 is very high distance. It means very low similar data. So distance should be inversely proportional to the similarity. This high similarity means low distance, low similarity means high distance. So similarity should be inverse of the distance between 2 points. I think all you are understand regarding it. Now come to the distance. What is the main concept of distance? So distance is the distance equivalent to the dissimilarity. So what is the distance? Distance to the equal to the dissimilarity. And now what is our main motto? Again, our main motto is required to find the closed group. Means what distance is very less. What the distance is very less means similarity is very high. This is our a group. Now we make the same graph. Again, we make a clusters. That is in this way. It is the true things. Definitely no. If we make the cluster in such way, this is not a true things. Means because these 2 points, these two, suppose this is a point, suppose this is another point. Between these 2 points, the distance is very high, but this point and this point, distance is very low. So these two is not a good clustering. But go to there, go to in this place, go to in this place. All in this group, all the data which is belongs in a particular group, the similarity between all the data is very high. Means distance between all the data is very low. And this is also same for this. But between this data and this data, distance between these two data is very high. Means similarity is very low. So this is to the different group. So based on the distance or based on the similarity, we can explain it. Okay, now what is the what we can summarize it? We can summarize it. Minimize interclass distance. Minimize intra-cluster distance, maximize inter-cluster distance. In the previously, what I tell that high intra-similarity, low inter-similarity, opposite it, maximize inter-cluster distance, minimize inter-class distance. Now, how we can measure it? How we can measure the interclass distance or interclass distance? How we can decide that the minimize intraclass distance, maximize interclass distance? How we can measure it? We can measure it using the parameter. This is called the scatter coefficient. This is called the scatter coefficient. Using the scatter coefficient, we can define this parameter. What is the scatter coefficient? Scatter coefficient is the ratio of average intracluster to average intercluster distance. Ratio between the average intracluster distance to the average intercluster distance. Let's check the scatter. This is the scatter. This is the scatter. Scatter equal to average intracluster distance by average intercluster distance. So if this scatter value is very lower, what do you mean by this? This is a better clustering. If scatter value should be lower, then it is the better clustering, because the average intercluster distance should be maximized. It's the average intercluster distance should be minimized. Yes. So average intercluster distance should be minimized. Average interclass distance should be maximized. So lower part should be maximized, upper part should be minimized. So scatter value should be very less. So lower the scatter value means it is better in clustering. This is the most important part.